Hello and welcome to this R tutorial. So we did the main steps, we cleaned all the text, all the reviews, we created our bag of words model, and now we have to do one more thing, which is of course to build our machine learning classification model, and we can do that because we have all our independent variables in this sparse matrix DTM here, built thanks to this function document term matrix, and besides we applied a filter here to remove the non-frequent words, well, a few of them, but still, this considerably reduced the number of words in the matrix, so that's always good for our model to run faster. Alright, so now let's build the model. So what we'll do is go to our files to get back to the part 3 classification, because what we'll do, of course, is take a classification model that we already built and we will apply on our text here, because out of this text we managed to create a matrix of features containing the independent variables, and of course we have one dependent variable, which is the second column of our dataset, the liked column, which tells if yes or no the review is positive. So we have everything, and therefore we only need to take our model now, and therefore we go to part 3 classification, and here we can find all our classification models. Alright, so which one to pick, which one to choose for natural language processing? Well, in general, based on experience, the most common classification models used for natural language processing are naive Bayes, decision tree, or random forest. You also have the CART model, which is another type of decision tree model, and you also have the maximum entropy model, which is based on entropy as well, like for decision trees. So these models work very well for natural language processing, and therefore here we'll pick one that is related to entropy, and that's the case for our decision tree classification model as well as our random forest classification model, because of course a random forest is a combination of trees making the same predictions together. And keep in mind that you can also use naive Bayes, which is commonly used as well for natural language processing. But here in this tutorial we will choose random forest classification. So let's go into this section, and here are all the files, the dataset, the classification template, and our model in Python and R. So let's take the one in R, so I'm just clicking on the file, here we go, model open here. So what do we need here? Well, first of all, let's notice that, when we are using the random forest classification model, we are starting with a dataset, which is a data frame, and that contains both the independent variables and the dependent variable. So what we have to do right now is go back to our natural language processing file and create exactly the same. That is, create a dataset containing independent variables and one dependent variable, and that will be the input of this model here, because we have our dataset here, and then we use our dataset in each of the code sections here, and then we split the dataset into a training set and a test set, and we train our machine learning classification model on the training set here. So what we only have to do is just to create this dataset containing the independent variables and the dependent variable. So that's very simple. We already have our independent variables, but the problem is that our independent variables right now are in a matrix, because this document term matrix function returns a matrix, so DTM is a matrix right now, and as you remember in our classification models on R, well, this data set is a data frame. It's not a matrix. So we need to make sure that here, for the input of the model that we are going to apply on this bag of words model that we just created in the previous tutorials, well, we need to make sure that we have a data frame. But that's actually very simple. We just need to take our matrix and use the function as.data.frame. And we will input our sparse matrix DTM inside, and that will transform our DTM sparse matrix into a data frame. So let's do this, and since we are just going to copy paste our random forest classification here, well, since the input of this model is basically this dataset, well, here we will use the same name to create this data frame, and so we will call it dataset. Dataset equals, And then that's when we use the as.data.frame. Here it is, that's the first one. Here we go. And so now we need to input the matrix we want to transform into a data frame. And that's of course DTM. And just to make sure we have the matrix type expected by this as.dataframe function, well, we need to use here the function as.matrix and put DTM as input of this as_matrix function. Because, you know, this sparse matrix DTM here is definitely a matrix, but it doesn't have the type expected by this as.dataframe function. And to make sure we have the right matrix type, well, we need to use this add.matrix function. All right, and now let's be careful. We lost one parenthesis, so I'm just adding it. All right, now we're good. We are ready to transform our sparse matrix of features into a data frame. So let's do it. I'm going to select this line and execute. All right, and now what's interesting to see is that we have the real data set, you know, with all the reviews in the rows and all the words that we took from the corpus and then were filtered thanks to this remove sparse terms function. Well, we can see the full data set here with this 1000 rows and all these 691 columns, each one corresponding to a word that comes from the reviews in the corpus, and that was not filtered by the remove sparse terms function. All right, so here you can have a look at this huge table, and we can clearly see here that this is a sparse matrix because basically we can only see zeros. Well, we have very few ones. We have one here, but all the rest is zeros. And so, for example, if I take this one here, well, this one belongs to the also column and to the 23rd row, that is the 23rd review. And so this one here means that the word also appears in the review 23. All right, so that's the sparse matrix, and now you can really see what it is with your own eyes. All right, so let's go back to our natural language processing file. So we have our data set, which is now a data frame as we wanted, but still incomplete. You know why? It's because the data set we start with in this random forest classification model and in general with classification models is a data frame, so we're good on that, but a data frame containing both the independent variables and the dependent variable. So what we need to do right now is add the dependent variable to this data frame data set, because right now it only contains the independent variables. All right, so you might remember how to add the dependent variable column to a data set, that is a data frame. Remember, we need to take our data set, then add a $sign here, and then after this $sign we can either take one of the existing column here if we want to update the column, or create a new column to add to this data set. And that's exactly what we want to do. We want to create a new column to this data set. Well, that's an existing column, that's the liked column, but we created for this data set because it is new column. And so we'll give to this column the same name as the real dependent variable column, that is liked. All right, so by doing this, we are adding this new column that we call liked, and then equals. And then after this equal, we need to specify what we want to add in this new column. And what we want to add is nothing else than the existing liked column of our dataset. But be careful, because our dataset was just updated to this new data frame, and therefore we no longer have the dataset that we imported originally. So what we'll do is very simple. We'll just rename this dataset by adding an underscore and then original. Here we go, and we will select this line again and execute. All right, so now we have our original data set, and therefore we can have access to the liked column of this original data set, which is going to be our dependent variable. So let's add this dependent variable right now to our data set. And so to take this dependent variable, we need to take our data set original. Here it is, because that's the original data set containing the dependent variable liked. And so to take this dependent variable vector, we need to add a $sign here, same, and then take the column we want, which is the liked column. All right, so that's good. By selecting this line and executing it, we add the liked dependent variable vector column to our data set already containing the independent variables that are all the filtered words of our cleaned reviews in the corpus. All right, so now we have everything we need and we are ready to take our machine learning classification model, because we have our data set that not only is a data frame but also contains both the independent variables and the dependent variable. So we have everything what is expecting our random forest classification model here. So what we only need to do here is take everything from here and not from here, because this section is to import the data set, but we already have our data set that is ready for our classification model. So we just need to take everything from here because this is where the data set starts to be processed. And so we take everything from here to here. And we cannot take this because this is to plot the results in 2D. That is 2 independent variables. And here, since of course we have a lot more than 2 independent variables, well, we cannot use this to plot the results. But we will definitely have a look at the confusion matrix to see the number of correct predictions as well as the number of incorrect predictions so that we can evaluate the model performance. Alright, so let's get back to our natural language processing file and we will paste our random forest classification model right here. Alright, so now we just need to modify a very few things because everything is basically ready, but let's see what we can modify. Well, first here in this section that encodes the target feature as factor, well, of course we need to replace this purchased dependent variable, which was the dependent variable in part 3. Well, we need to replace it with our new dependent variable, which is liked. All right, and same here. We replace purchased by liked. All right, good for this section. Then in the next section, we split the data sets into the training set and the test set. Well, that's very important to do this unless you want to create a new review. But we will train our random forest classification models on, say, for example, 800 reviews, and we will test the predictive power of random forest on 200 new reviews on which our random forest classification model was not trained, and therefore these 200 reviews in the test set will be new reviews for our random forest classification model, and so we will see how it manages to predict whether each of these 200 reviews is positive or negative. And then that's in the confusion matrix that we'll see the number of correct predictions and the number of incorrect predictions in this 200 new reviews. Alright, so that's what is done in this section. And since I just gave as an example 800 reviews to train the model and 200 reviews to test it, well, let's go with this choice of numbers. And so we need to change the split ratio here to 0.8 because that's 80% and we have 1000 reviews. So 80% of 1000 reviews is 800 reviews to go to the training set and therefore 200 reviews to go to the test set. Alright, so that's good. And of course, let's not forget to replace the purchased variable here by our new dependent variable that is liked. Alright, so I think we're good with this section. So now let's move on to the next one. The next one is about feature scaling. And so here, do we need to apply feature scaling? Well, not really, because we only have zeros and ones in the sparse matrix of features, and therefore we don't have one independent variable dominating another independent variable, so we don't need to apply feature scaling, so we will remove this section. All right, and so what about this one? Yes, of course we keep this one because this is the section where we build our random forest classification model that will classify the reviews, and that's where we train the random forest classification model on the training set. And therefore, here we need to change two things. First, the index here that is the index of the dependent variable that we need to remove from X, because X is supposed to be the training set without the dependent variable. So we need to remove it, but the index of our new dependent variable liked is not 3, but is 692. We can see that here very easily. So let's replace 3 by 692. All right. Good, and now the second thing that we need to change is, of course, this purchased here that we still need to replace by liked. This way. And then if we want, we can train our random forest classification with more trees. Right now we have 10 trees, so we will keep 10 trees. That might be enough for our 1000 reviews, which is quite a small number of reviews, and especially our 692 words columns that we have in our sparse matrix of features. 10 trees might be enough, but of course you're welcome to try more random forest classification models with more trees. So we're good with this section, and now let's move on to the next one. The next one is about predicting the test set results, so making the predictions on 200 new reviews that our model won't know anything about, and therefore for these new reviews our model is going to try to predict if those reviews are positive or negative, and therefore it will be very interesting to see if it's making some correct predictions on new reviews. So right now it's the same. We have to replace this index here that corresponds to the index of the dependent variable, and so we need to replace 3 by, of course, 692. That's exactly the same as we did for the training set here, and so now we're good for this section. We're finally getting to the last section that is making the confusion matrix. That's the interesting section that will tell us the number of correct predictions and the number of incorrect predictions for these 200 new reviews. So we will see that right now, but of course we need to replace this 3 index that corresponds to the index of the dependent variable, still the same, and replace it by 692. Alright, so now everything is good. We are ready to train our random forest classification model on our 800 reviews of the training set, and then evaluate the predictive power of our model on our 200 new reviews in the test set. So let's do it. Since we already executed everything up to here, what we need to do now is just select everything from here to the bottom, and now we're good. We just need to press Command or Control plus Enter to execute, to train the model and test it on the test set, and eventually have a look at the number of correct predictions and the number of incorrect predictions on 200 new reviews. So let's do it. I'm gonna press Command plus Enter to execute. And here we go, everything worked properly. Great, so let's have a look. We will have a look at the confusion matrix, of course, by typing here CM in the console. Here we go. So let's see what we have. We have 79 correct predictions of negative reviews, 70 correct predictions of positive reviews, 21 incorrect predictions of negative reviews, and 30 incorrect predictions of positive reviews. Alright, so that's actually not too bad. You know, because we only had 800 reviews to train the model, that's not much when you're working with text, and therefore 30 plus 21 equals 51 incorrect prediction is not bad out of 200 new reviews when you know that you trained your classification model on only 800 reviews. And actually, let's have a look at the accuracy. The accuracy is the number of correct predictions, that is 79 plus 70, divided by the total number of observations in the test set, and that is 200. So let's have a look at the accuracy, pressing Enter here, and the accuracy is 74.5%. So again, that's not bad considering the fact that we trained our model on only 800 reviews, and you'll clearly see that if you had a lot more reviews to train your classification model, you will get a much better accuracy. Alright, so that's the end of natural language processing in R. Congratulations for having completed all this, creating the Bag-O-Words model, training a classification model on this dataset. But that's not the end of your natural language processing journey, because right after this video you'll get a little challenge. So I will let you find out about that